All right, part 2 of our comparison test, where we learn about not the comparison test, but the limit comparison test. This one's a little wacky. So it says, let the sum of a sub k and the sum of b sub k be series with positive terms, and let it some L be the limit as k tends towards infinity of a sub k divided by b sub k. And that equals L. Yeah. So if we find out that limit, that L that we get, is in between 0 and infinity, smaller than infinity, an actual number, bigger than 0, then they both converge or they both diverge. If you find that the limit just goes to 0, then they both converge. If the limit goes to infinity, both the b sub k and the a sub k will diverge. But you're like, what the hell is b sub k? What's a sub k? What's going on? What kind of problems are you talking about? So our game is we have to come up with a b sub k. So let's see a problem and we'll run through it. So let's look at, what do we want to do? Limit is k is equal to 1. Let's go up to infinity and let's go 5k to the 4th minus 2k squared plus 7 all over. Let's go 2k to the 6th minus a k plus 12. And I'm like, whoa. Okay, that's our a sub k. Right inside of here. Our a sub k is what we're given. Okay, so this is going to be our a sub k, but next we're going to have to come up with some b sub k, but what we want is something that behaves nicely, something we can deal with. So we're going to use what's given to find some b sub k. Something else that behaves in the same way. So I'm actually just going to do one of these. I'm going to write out the same thing as what's up above, and then we're going to change it a little bit just by doing some erasing. We're going to think about this. Remember doing limits? As x tends towards infinity, we messed around with things like that. You know how we would be like, hey, you know what doesn't matter? That 7 doesn't matter. That 12 doesn't matter. The only thing that actually matters is the leading degrees. So we're like, well, I don't care about the 2k squared. I don't care about the... Oh, there's b sub k. So we just look at the leading terms at the beginning. We don't care about the negative 2k squared. We don't care about the plus 7. Down to the denominator, we don't care about that negative k. We don't care about that positive 12. The only thing that's going to matter as we tend towards infinity is going to be the largest terms. So now we can clean this thing up and we can go, all right, well, there's some b sub k, which is 5 over 2k squared. Okay. There's our b sub k. So that's going to be kind of the game that we use. That's the game we use. Some b sub k that we have to come up with ourselves, but all it's going to do is just use the leading terms of the numerator and the leading terms of the denominator. Okay. So what we'll do is it tells us, all right, just find the limit as k goes to infinity of our a sub k. All right, well, we have our a sub k. That's 5k to the 4th minus 2k squared plus 7 all over. Oh my goodness, this is so much. Don't worry, it's all going to pop out. And then we want to divide it by our b sub k. We want to see what that limit's going to be. So let's go old school real quick. And let's write dividing a little bit different. So we have our 5k to the 4th minus 2k squared plus 7 all over 2k to the 6th minus k plus 12. And then let's multiply by the reciprocal of the denominator, right? So we'll go 2k squared over 5. Well, I'd like to rip out the 2/5 in here. Do you mind? I take out these 2/5. I just want it out of there. And then we're going to bring it all in. So 2/5. Limit as k goes to infinity. So that's all removed. Now we're just going to think. Just bring in your k squared. Just bring in your k squared to all of them. Let's see what we got. It's 5k to the 6th minus 2k to the 4th plus 7k squared all over 2k to the 6th minus k plus 12. Now, when we're doing limits, come on, dude, you can just state the answer. Are you really going to do one of these back from, you going to do this? To find out it goes to 5 halves? You really going to do that? Or what are you going to do? You're going to do L'Hopital 6 times? The only thing that matters is the k's going to infinity are these leading terms. And look, the powers match. Those powers match, so we're left with the 2/5 is hanging out front. Now, what does this go to? It goes to 5 halves. We put this in, and this equals 1. So what does that say? This is our limit that we just found. Our L is equal to 1. So it tells us that if our L is in between 0 and infinity, either both converge or both diverge. Well, shoot. Does B sub k, does this converge? Does that converge? If we were to take the sum from k equals 1 up to infinity of 5 over 2 times 1 over k squared, does that converge by P series? Hell yeah, it does. Hell yeah, it does. So our B sub k converged. Therefore, our original converges as well by the limit comparison test, LCT. Okay. Now I'm going to give you one effed up one. You're like, what? That was messed up enough. Yeah, let's make it worse. Let's make it worse. Let's get nutty. Let's get weird. So, what do we got? Let's do... Oh, I know what we can do. Let's do this. Oops. Sum, not limit. The sum from k equals... Hold on. Let me see where I want to go from. Yeah, I think 1 will work. Up to infinity, and let's go ln of k over k squared. Eesh. Now, how the hell are we supposed to find some... What the heck are we supposed to find some B sub k? And I'm going to tell you how you're going to find some B sub k. Here's kind of our game. It's a little tough to explain. So, let's discuss this. So the sum, I'm gonna try and make this too tough. I know, just hang on. Just hang on. I know I'm writing this backwards as well. This is true. And we could go through and do a bunch of work. However, what I would like to think, if we go through and do all this work, you're going to find out inconclusive, then inconclusive, and we're not really going to get much of anywhere. So what I'd like to think of this as is something we can make it approximately equal to. So if you ever have that ln of k up here, we can say, let's make it approximately equal to k to the 1/2 over k squared. If you ever want to do an LCT on an ln, make it k to the 1/2 power. And you're like, what? Where's that coming from? Oh, I'm sorry. I wrote 1 over k incorrectly. I wrote k squared. Or k over k squared. I forgot to put and I just wrote 1 over k. Dude. So this is actually just a k to the negative first, and this is a k to the negative second. If we could find something somewhere in between there, isn't k to the negative 3/2 like in between there? And that's what we have. We can go into great depth about this, but that's the trick with the LNs. We're going to think of the LN to be in between when we do these sums. We're going to think of it in between 1 and k. 1 and k. Which is going to work kind of like that for k greater than 1. I know it's a lot. I know that's a rough one, and it's just kind of out of the blue, and we're like, what the hell? So we have our a sub k, and now I'm just going to claim our b sub k is going to be 1 over k to the 3/2 power. And there's not much here other, I mean, you can try and understand it, or you can kind of just go along with it. I want to call this 1 over k to the 3/2 power. So we can replace, when doing LCT, once again, you can replace your ln of k with a square root of k. They're graphed so similarly. That's the square root of x. That's ln of k. Do you notice they kind of behave the same way? They're concave down. They're both always increasing. They behave in a very similar way. So if you want to do LCT, you can always just kind of replace your ln of k with the square root of k. And I think that would be a great spot for our b sub k. So now that we have our two things, we're like, okay, well, let's go find our limit as k tends towards infinity of our a sub k divided by our b sub k. Now, I jumped it the first time, but does our b sub k, does that converge or diverge? Sorry about all my dang writing. Does the sum is k equals 1 up to infinity of our b sub k, does that converge? Yeah, it converges by p series. All right, so it converges. So since one of them converges, if we can find the limit of this, and this actually goes to any sort of number that's not infinity, we know for certain that this thing is going to converge. So we do a little bit of work. We flip this over. So we get our ln of k over k squared, and then we flip this over, and the k to the 3/2 power pops up top, and we get our 1. So of course we can clean this up, and this becomes k to the 1/2 power. So what do we have? This is the limit as k goes to infinity of ln of k over the square root of k. K, not x. I'm just making it look more like an x. So we go low b talls. Where are we gonna go? We got infinity over an infinity k, so we get 1 over k divided by 1 over 2 square roots of k, which is equal to the limit as k tends towards infinity of 2 over the square root of k over k. Hey, look, we got more k's down below than we do up top. Why am I still writing? Whack. That goes to 0. Therefore, by r, where is it? Sorry, all that frickin' writing. If the limit is 0 and b sub k converges, that's what we had, then the sum of a sub k converges. And the a sub k is our original frickin' problem. We say this converges by LCT. All that work just to say, yeah, it converges, dude. I saw that. Did you catch any of it? I hope you did. Dang, these 15-minute videos. Sorry about that. All right, so our next one, we will be jumping into the alternating series test, AST. And then we got the ratio and roots, and then we'll wrap it up. We'll kind of look at all of them in one shot. I think I'll do something where I'll give you an example of an exam, or I'll give you a few of them, and we're only going to use one test per problem. All right.